Hi everyone, welcome to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. This channel is intended to those who are doing their online classes out there and also those who are answering their modules. This is very helpful for you to develop your basic concepts in your math lessons. And please do not forget to share this channel to your friends out there so that you can help them also to develop their skills and improve their performance in mathematics. That is a very nice advocacy to share your knowledge and to share this video discussion. So please do not forget to subscribe my channel before you forget it. Okay, so now let's proceed to our the discussion in this video. So our topic will be something related to algebra. Actually, this is a very, or the start for a prerequisite lesson for algebra, or in algebra rather. So we will talk about exponents and polynomials. So are you ready? I know you're ready. So as I have said, our lessons in this video is about, or we'll focus on the exponents and polynomials. So now, here are the chapter sections or the summary for the topics in this video discussions. Perhaps we will just we will just end our discussion in adding and subtracting polynomials. So we will talk about exponents, negative exponents, and scientific notation, and introduction to polynomials. We will also discuss about adding and subtracting polynomials. And perhaps in our next video discussion, we will talk about multiplying polynomials and special products, and we will include the dividing of polynomials. So now let's proceed. So let's start to talk about exponents. So when we say exponents, that are natural numbers that are shorthand notation for repeating factors. Example, 3 to the power of 4 can be written as 3 times 3 times 3 times 3, meaning to say we have 3 to the power of 4 as exponential notation. This is an exponential notation, and this one is a longhand notation. Okay, so that's how we illustrate an exponents or exponential notation. So now 3 is the base, as you can see, and 4 in the exponential notation will be treated as your exponent, or also called the power. And note, always remember, by the order of operations that exponents are calculated before other operations. Again, note, by the order of operations that exponents are calculated before other operations. Remember the PEMDAS. Exponent will be calculated first before doing the fundamental operations. That's what it meant in here. So let's have an example. Evaluate each of the following expressions. Let's start 3 to the power of 4. When you evaluate, of course, you can rewrite it in its long notation. Yes, as 3 times 3 times 3 times 3, which is equal to 81. So 81 is the answer to evaluate 3 to the power of 4. Next, quantity -5 squared. Remember, imagine, always remember when the negative is inside the parenthesis, then it's included to the exponent where the base will be repeated twice. So you can rewrite it as -5 times -5. That gives you positive 25. So for this one, -6 squared, as you can see, it's really different from the second. This is different from this. Why? Because as you can observe in here, the negative is inside the parenthesis, while in -6 squared, the negative, it's not inside in the parenthesis, or in short, there is no parenthesis. So how does it differ from the previous example, -5 squared, quantity squared rather? So that means, it means that only 6 will be repeated twice, not included the negative sign, because it's not in the, or inside in the parenthesis, just like in the second example. So we have it -36. Okay, so please not forget about that one, how you evaluate exponential expression. So next is we have it 2 times 4 closed quantity cube That gives us 2 times 4, which is 8. And then you get the, or you can have it 2 times 4 times 2 times 4 times 2 times 4. In short, 8 times 8 times 8. That gives you 512. Okay? So next is 3 times 4 squared. To evaluate this exponential expression, you can just have it 3 times 4 times 4. That gives us 48. I hope you'll be able to grasp its concept and process on how we evaluate exponential expression. So I hope you are there. You are there to really grasp and do not forget the concept about this one. So next now, let's try to evaluate each of the following expression. Find 3x squared when x is equal to 5. All you have to do is just to substitute the value of your x, which is equal to 5, to the expression 3x squared. This is what I meant. Or this is what I mean rather. Okay, you just change the value of your x as 5 in here. So now let's proceed. So that gives you 3x squared is equal to 3 times the quantity of 5 squared. That gives you 3 times the quantity of 5 times 5, which is equal to 3 times 25, which gives us an answer of 75. Okay? So next, find negative 2x squared when x is equal to negative 1. So in this case, your x is negative 1, so just replace it by negative 1. That gives you negative 2 times negative 1 times negative 1, and that gives you negative 2 times 1. Since negative 1 times negative 1 is positive 1, so that gives you negative 2. Okay, so I hope you can follow. I am expecting that you got it correctly. So do not forget how you evaluate exponential expression. Now, in simplifying expressions or algebraic expressions, we also include the topic about the laws of exponent, as I recall. Though we already had this one in our previous video discussions, we will just have a very fast and a very quick review about the laws of exponents. Let's start with the product rule. It applies to common bases only, okay? Do not forget. A to the power of m times a to the power of n, same base rather, or same bases. You will just copy the base and then add the exponent. That's why we have it a to the power of m plus n. That is the rule. So that if we have to use this one in simplifying expressions, example 3 squared times 3 to the power of 4, that gives you 3 to the power of 2 plus 4. Then that gives you 3 to the power of 6. Then you evaluate. Then that gives you 3 times 3 times 3 times 3 times 3 times 3, which gives us 729. Amazing, right? Okay, now there x to the power of 4 times x to the power of 5. Applying the product rule, we'll just add the exponent. That gives you x to the power of 9. Another same process, just copy the base and add the exponent. That gives you 7 to the power of 10. And of course, for this one, in this case, since 3 and negative 4 are not like terms, we will just, not like the same bases. So we will just multiply them right away. That gives you negative 12. And then you can just have it 3 times negative 4. Then applying the product rule for y, that gives you negative 12y to the power of 6. So I hope you'll be able to grasp its concept. So now another rule or laws of exponents that we have in here is the power rule. For power rule, according to it, you will just multiply their exponents. Let's have an example. 2 cubed raised to 3, or raised to cube rather, that gives you 2 times 2 to the power of 3 times 3, which gives you 2 to the power of 9. And after that, applying the law, evaluating of exponential notations or expressions, that gives you 512. Another x to the power of 4 raised to, or quantity square, that gives you x to the power of 4 times 2, which is equal to x to the power of 8. Another rule is the power of a product rule. So AB, quantity n to the power of n rather, is equal to a to the power of n times b to the power of n. So let's have an example. 5x squared y close quantity cube. To simplify this one, applying the power of a product rule, then you will just distribute the exponent to each terms, each expressions there in the term. So we have 5x squared and y. You just distribute the cube. So you have it there, 5 cubed x squared raised to cube times y cubed. So that gives you what? 125x to the power of 6 y cubed. That is how you apply the power of a product rule. Another laws of exponent that we mentioned in our previous video discussion is the power of a quotient rule. Power of a quotient rule, according to it, when you divide power of a quotient rule, it states that when you have it a to the a over b quantity n, the raised to n rather, is equal to a to the power of n over b to the power of n, you can just distribute the exponent in each terms in your both numerator and denominator. There's also another thing for the quotient rule where when you divide expressions having the same base, then just copy the base and then subtract their exponents. So this is another rule for the quotient. So I hope you'll be able to distinguish the rules for the quotient in evaluating exponential expressions or even in algebraic expressions. So now let's have an example. So in the example that we have, as I have said, we have it 5x squared y quantity cube. To simplify it, that gives you 125x to the power of 6y cubed. So this one, so as you can see, p squared, you just distribute the 4. So you have it p squared close quantity to the power of 4, and then 3r cubed close quantity to the raised to 4. So you can just have it. So applying the power of product rule, you can just multiply it. That you can distribute the denominator, the 4 here, the fourth power. So you have it there, 3 to the power of 4, r times the quantity of r cubed close quantity to the power of 4, which gives you, or applying the power rule for the denominator and numerator. So you have it p to the power of 8. Since 4 times 2 is 8, that's why you have your numerator as p to the power of 8. And of course, 3 to the power of 4 is 81. Then 3 times 4 is 12. That's why r to the power of 12. So this is our final answer. So I hope you can follow. And here, as I mentioned a while ago, another quotient rule applies to common bases only. So let's have an example. So you have it 9 over 3, then a to the power of 4 to the over a, b to the power of 7 over b squared. Then group common bases together. And then that gives you, or applying the quotient rule, applying to common bases, then we have it 9 divided by 3, that gives you 3. I hope you can follow this one. That gives you 3. This one, that gives you a to the power of 4 minus 1. And for this, that brings you b to the power of 7 minus 2. So after that, you simplify, that gives you 3a cubed b to the power of 5. So that's how you apply quotient rule with common bases. So I hope you will be able to get it correctly. I am anticipating that one. This is just very easy because we've been doing this one in our previous video discussion. So for the zero exponent rule, 0 to the power of 0 is always undefined. So any numbers that is raised to the power of 0, the answer is 1. Just like this one, 5 to the power of 0 is 1. This one, since its exponent is 0, then you have it like that. Then 1 times 1 times 1 is equal to 1. So negative x to the power of 0, that gives you negative 1. Why? Because x has an exponent of 0, which is equal to 1. Then multiply it to the negative. Since negative, it's not inside the parentheses. That's why your answer is negative 1. So please do not forget that one. For negative exponents, all using the quotient rule form, this one, of course, any exponent, or yeah, but what does x to the power of negative 2 mean? If you have a negative exponent, then get its reciprocal. Okay, so example, this one. It can be written as this, x to the power of 4 over x to the power of 6. So to simplify this one, you can just have it like factor it out or long notation, then cancel their common. This one, common. So what will be left will be this one. And then you give it will give you 1 over x squared. That's why in a quotient rule, we can have it when x to the power of n, then it gives you 1 over x to the power of n. So this is the rule. You cannot change about this one. Okay, all you have to do is just to apply it. That's the good thing. So in order to extend the quotient rule to cases where the difference of the exponents would give us a negative number, we define negative exponents as follows. If a is not equal to 0 and n is an integer, then we can say that the rule for negative exponent, this is what I said a while ago, when a is raised to the power of negative n, where the exponent is negative, just get its reciprocal and then you have its positive exponent. See, a to the power of negative n is equal to 1 over a to the power of n. This is how we make the exponent positive, just applying the negative exponent rule. So I hope you'll be able to remember this one or this concept or rule. So let's have an example. Of course, 1 over 3 squared, which gives you 1 over 9. Another, that gives you 1 over x to the power of 7. This one, okay, since only x has a negative exponent of 4, then only x will be, will get its reciprocal. So that gives you 2 over x to the power of 4. Again, remember that without parentheses, x is the base for the exponent of negative 4, not 2x. That's why 2 is not included. Okay? Or in other way, you can just have it or rewrite this one or solve this one in this way. That is 2 times 1 over x to the power of 4. That's why 2 times 1, that gives you 2. That's why our answer is 2 over x to the power of 4. Okay? So I hope you can follow. So another example. Okay, that gives you negative 1x cubed, as I mentioned a while ago. So this one, that gives you negative 1 over 3 squared, which is equal to negative 1 over 9. For this one, since the negative is inside the parentheses, therefore the whole expressions will be brought to denominator or will get its reciprocal. That's why we have it 1 over negative 3 quantity square, which gives you 1 over 9. So notice the difference in results when the parentheses are included around negative 3, right? Okay, so now another examples for, let's now proceed to simplifying expressions. To simplify by writing each of the following expressions with positive exponents. In short, when we simplify algebraic expressions, we follow or we apply the rules of exponents. Okay, the laws of exponents rather. For 1 over x to the power of negative 3, that gives you 1 over 1x cubed, applying the negative exponent and then get its reciprocal, that gives you x cubed. Okay, I hope you can follow. For number 2, of course, they will be just 1 over x squared over 1 over y to the power of 4, which gives you y to the power of 4 over x squared. You will just interchange them. Okay? Can you see the trick? Okay, there's a pattern actually. Note that to convert a power with a negative exponent to one with a positive exponent, you simply switch the power from a numerator to a denominator or vice versa and switch the exponent to its positive value. Same as how we did it in number 2. This is what I said. You just switch it and take the positive exponent. So now, in summary of exponents rule, if m and n are integers and a and b are real numbers, then we can say that the product rule exponents, for exponents rather, we a to the power of m times a to the power of n is equal to a to the power of m plus n. For power of rule for exponent, you can see there, a to the power of m raised to n is equal to a raised to mn. And for power of a product, quantity AB plus quantity to the power of n will give you a to the power of n times b to the power of n. For power of a quotient rule, for having different different bases, quantity a over b to the power close quantity to the power of n will give you a to the power of n over b to the power of n, where b is not equal to 0. For the quotient rule for exponents having the same bases or common bases, we will just subtract their exponent. For 0 exponent, that is the result will always be 1. For negative exponent, just get its reciprocal to get its positive exponent. So that's it. So simplify expressions. Simplify by writing the following expressions with positive exponents or calculating. So if we have it here like this, then all we have to do is just to apply the rules or laws of exponent. Applying power of a quotient rule. So we have it, this one. We distribute the negative 2 exponent in your numerator to each coefficients inside or in our term, inside the parentheses. So we have it, applying the power of a product rule, then you have it 3 to the power of 4, a to the power of negative 6, b squared, over rather, 3 to the power of 8 times a to the power of negative 14, b to the power of 6. And after that, applying the power rule for exponents, then it gives you 3 to the power of 4, a to the power of 14, b squared over 3 to the power of 8, a to the power of 6, and b to the power of 6. Then applying the negative exponents, as you can see, we have it, the quotient rule for exponents. What I mean, applying the quotient rule for exponents, then you have it 3 to the power of 4 minus 8 and a to the power of 14 minus 6, as you can see on the screen, and b to the power of negative 6. Then you have it 3 to the power of negative 4 a to the power of 8, b to the power of negative 4. So as you observe, since there are still negative exponents, then we will apply the negative exponent rule. That gives you a to the power of 8 over 3 to the power of 4, b to the power of 4. Or you can simply evaluate 3 to the power of 4 into 81. So our final answer will be a to the power of 8 over 81b to the power of 4. So I hope you'll be able to grasp this concept or the answer. Okay? So easy, right? All you have to do is just to follow. Just be patient in solving and make sure that your eyes are bigger than the usual thing so that you will not be misled by the correct with the correct answer. Okay, so I hope you'll be able to grasp it. So for scientific notation, in many fields of science, we encounter very large or very small numbers. Scientific notation is a convenient shorthand for expressing these types of numbers. So a positive number is written in scientific notation if it is written as a product of a number where 1 is less than or equal to a and a is less than 10 and an integer power r of 10. So we mentioned this one in scientific notation, a times 10 to the power of r is its 4. So for the introduction to polynomials, so we talk about scientific notations, we talk about algebraic expressions, we talk about laws of exponents, the exponential notation, exponential expressions, exponential expressions and all. So it will lead us into the introduction to polynomials. So again, introduction to polynomials that define what is a polynomial. So for the vocabularies under polynomials, it's very important for us to know the different terminologies that being used in here. So when we say term, a number or a product of a number and variables raised to powers. Again, a term consists of numbers, coefficients, and variables. Or again, it is a number or a product of a number and variables raised to powers. It could be just a number or it could be just a variable or it could be just a number and a variable. So we call it a term. So when we say coefficient, that is the numerical factor of a term. Example, 2x. 2 is the numerical coefficient or the coefficient, numerical factor of a term. So please do not forget. For constant, term which is only a number. So there is no variable included in the constant term. Okay, so do not forget that, constant. So in short, when we say polynomial, it is the sum of terms involving variables raised to a whole number exponent with no variables appearing in any denominator. Again, no variables appearing in its denominator. That is what we call polynomial expression. So in the polynomial 7x to the power of 5 plus x squared, y squared minus 4xy plus 7, there are 4 terms, okay? So namely 7x to the power of 5, that's the first term. X squared, y squared is the second term. Negative 4xy is the third term. And 7 is the fourth term, or we call it constant term, the 7. Okay, do not forget. So the coefficient of terms are 7x to the power of 5 is 7. Okay, again, the coefficient or numerical coefficient of 7x to the power of 5 is 7, obviously. Of term x squared, y squared is 1. So you're wondering, there's always one. Example, if we have x, there is always 1 in it. If you cannot see any numerical coefficient to a variable or in a term consisting only a variable, there is always a numerical coefficient of 1 and exponent of 1. Do not forget. I am referring it here. This one example, x. There is always an exponent of 1 in here, and there is always a numerical coefficient of 1 in here. Okay, so it's not 0. So do not forget that one. Of term negative 4xy, the numerical coefficient of the term negative 4xy is negative 4, obviously. And for 7, of course, since it doesn't have a variable, so we call it constant term, and automatically its coefficient or numerical coefficient is 7. So I hope you can follow. Okay, next, 7 is a constant term, as I have said. So types of polynomials, we have monomial. When we say monomial, it is a polynomial with 1 term. For binomial, it is a polynomial with 2 terms. For trinomial, it is a polynomial with 3 terms. And of course, for the degrees of polynomial, a degree of a term, it means to find the degree, take the sum of the exponents on the variables contained in the term. I hope you can follow. Degree of a constant is always 0. Take down note. The degree of a constant is always 0. And the degree of the term, example, 5a to the power of 4b cubed c is 8. Okay? So when you have this kind of term, and if you ask to get its degree, you have to add the exponent of the variables being used. We have 4, 3, and 1. So 4 plus 3 plus 1 is 8. Remember that c can be written as c to the power of 1. So that's how you get the degree of this term, 5a to the power of 4, b cubed, and c. So that's how you do it. Not forget. So the degree of a polynomial, it is to find the degree, take the largest degree of any term of the polynomial. So in short, in a very simple way to describe it, when we say degree of polynomial, that is the highest degree, the largest degree among the terms in a given polynomial. Take down note of that. So example, 9x cubed negative 4x squared plus 7, the degree is 3. Why 3? Because when you check the degree of each terms, okay, the degree here is 3. Its degree is 2. The exponent of 7, or the degree of 7 is, again, 0. Since 7 is a constant term, remember the degree of a constant term is 0. So 3, 2, 0. So with that, the highest exponent is 3. Therefore, 3 is the degree of this given polynomial. So I hope you'll be able to remember that one. And if you are asked about what is the leading term, you always look at the term of the highest degree. So since 9x cubed is the where we took our degree of the polynomial, therefore 9x cubed is the leading term. So if you are asked about the leading coefficient, your answer is 9. The coefficient of the leading term is the leading coefficient. Okay? The term for the degree of the polynomial is the leading term. Where you get your highest degree, that's already considered as your leading term. And you can find your leading coefficient based in your or from your leading term. Do not forget that one, okay? So I hope you are learning a lot of things today or in this video discussion. So evaluating a polynomial for a particular value involves replacing the value for the variables involved. Example, this one. How to evaluate, find the value of 2x cubed minus 3x plus 4 when x is equal to negative 2. All you have to do is just to substitute the value of your x in here. Since x is negative 2, therefore the value of your x in here is negative 2. So let's see. Just replace it. So to replace it, then you can evaluate or solve it. So you have it negative 2, quantity cube is negative 8, then negative 3 times negative 2 will give you plus 6. So to solve this one, that gives you negative 6. So I hope you can follow. So are you following? Yes, I hope you do. Now, we will talk about like terms in combining like terms. In combining, you can only combine polynomials when they are like terms. Take down note. You can only combine polynomials when they are like terms. So to define like terms are terms that contain exactly the same variable, again, same variable raised to exactly the same powers. In short, when we say like terms, they have the same variable and they have the same exponent. Just remember the two, same variable and same exponent, then we call it like terms. So example, or warning, only like terms can be combined through addition and subtraction. That's why I said you can only combine polynomials when they are like terms. You can only add or subtract polynomials when they are like terms. Take down note of that. Example, x squared y plus xy minus y plus 10x x squared y minus 2y plus xy. So to simplify this radical, polynomial expressions rather, we will just first group them together according to their like terms. So we have it x squared y, 10x squared y, since they are the same, and xy plus xy, the negative y and negative 2y. So I will highlight this one, there are like terms. This one, there are like terms. This is also, there are like terms. So with that, we can combine them. So to combine them, of course, you can only listen when combining like terms. you can only add or subtract or combine their numerical coefficients. The rest, you will just copy the other terms, or especially their variables or their common terms. So as you can see, in here, we just add 10 and 1, 1 plus 10. So we just copy the variables used, the term that they use, x squared y. In here, so there is always 1 in here, right? As I have said, we can, when there is no, when there is only, when there are only variables given, then that is understandable. There's a numerical coefficient of 1 and exponent of 1. So 1 plus 1, so xy. Then for this negative y minus 2y, you have it negative 1 in here and negative 2. So y, copy the y. And after that, you just solve it. 1 plus 10 is 11, 1 plus 1 is 2, the negative 2 and minus 1, minus 2 is negative 3. So you have it 11x squared y plus 2xy minus 3y. Easy, right? So I hope you'll be able to remember the process. Now, if you got it, the like terms, we can now proceed to adding and subtracting polynomials. Remember, you can only add or subtract polynomials when they are like terms. So I hope you will be able to remember that one. So in adding and subtracting, of course, combine all like terms, all the like terms. Subtracting polynomials, change the signs of the terms of the polynomial as how we do it in the integers, being subtracted and then combine all the like terms. That's it. Let's have an example, this one. So to add this one, we can just group the like terms. So the like terms, so first remove the parentheses rather. So then group the like terms. So we have the like terms. Of course, you have to order or write the polynomials in ascending, yeah, what I mean in descending order. So what will be the highest, or the highest exponent will be written first as your first term. Okay, so this one. So since there is no like term for x squared, so let's proceed to 3x. 3x has a like term, 3x and minus 3x. And of course, the constant term has a like term, which is 3, negative 8 plus 3. So to solve this one, you can have it 4x squared minus 5. Why minus 5? Because 3x minus 3x is 0. Okay, so I hope you do. You can follow. And for subtraction, subtracting of polynomials, this is what I said. It's like integers. You change first the parentheses. How? You distribute the negative. Negative times negative y will be positive y. Negative times negative 4 will be positive 4. Let's see. Okay, yes, yes. 4 plus y plus 4. Then like terms, 4 and 4 are like terms. That's why you have it y plus 8 as your final answer. What about this one? Okay, so you have to change, or you have to remove the parentheses for negative in here. This one, you can just, sorry, you can distribute this one to remove the parentheses in here. Yes, sorry. So you can have it negative a squared plus 1, negative a squared plus 3 plus 5a squared minus 6a plus 7. So we just remove the parentheses. So again, to remove the parentheses, how did we do it? This one, of course, you have it there, as you can see. This one. And for here, you have it negative a squared. See? And of course, for this one, you have it positive. And then just copy this one because it's positive. So nothing will change in here. So that's how you remove the parentheses first. Remember the PEMDAS? Oh, it's like we're doing the integers. Okay, so after that, we combine like terms. And after combining like terms, that gives you 3a squared minus 6a plus 11. Tip, okay, note rather. Please, when you box your final answer, make sure that your polynomials is in its standard form or in arrange in standard form. How to arrange it in its standard form? It must be in the exponent, or the exponents must be in descending order. So it must be the highest exponent as your first term, just like here, 3a squared, followed by the order of the exponent 1, so 2, 1, 0. So 3a squared minus 6a plus 11. Okay, so I hope you'll be able to remember and grasp the concept about adding and subtracting of polynomials, and also the evaluating thing for exponents, and also, of course, to simplify algebraic expressions, applying the laws of exponents. So always remember that the essence of mathematics is to make, not to make simple things complicated, but to make complicated things simple. Always remember, math is fun. Try to love the subject. Do not forget to subscribe my channel. Have a great day, everyone. Thank you for listening. Thank you.